Welcome, everyone, to today's webcast, Better, Faster, More Secure Code by Combining SAST and SCA. I'm your host, Paul Asadoorian, joined by Mr. Matt Alderman, the CEO of Security Weekly. Matt, welcome.
Thank you, Paul. Hello, everyone. Stay warm today. It's going to snow in Colorado.
Yes. It's snow in April. It's wonderful. Our sponsor today is Synopsys, and Utsav Sanghani is here. He's the Senior Product Manager at Synopsys. Utsav, welcome.
Hi. Thanks for having me.
Yeah, it's nice to have you here today. I'm going to jump right into it because we've got a lot of content to cover, and I definitely want to get to the demo that Utsav has prepared today. So the first part of this webcast will be trying to write secure code and managing secure configurations, largely with open source or free tools that are available with copious amounts of examples. If you want any of the scripts, they are not in a public Git repo, but if you request them, I will send them to you. I have Docker configurations for Python app and a PHP app that I will use as an example. I'm happy to share those. Those are both in production today for Security Weekly. So this isn't some test thing. This is actually part of our production config. Synopsys will talk about, and Utsav will talk about how to secure your entire application and all the different pieces and parts, which we'll get to. So just to set the stage, securing applications using free and or open source tools, we do have a Python Flask application called PPWorks that you might have heard us talk about before. It does our podcast production and business workflow. That'll be one of the examples. We also, if you go to wiki.securityweekly.com, that is our media wiki build, which is now running on containers. So I'll use that as an example. We've also standardized on the JetBrains tools. So I use PyCharm and just started using PHP Storm to manage and just get a little better code beautification and navigation in PHP. They have a separate IDE for that. They were having a sale, so I upgraded to the whole package from JetBrains because I really love their tools. And when you manage large projects, I'm a huge fan of VI, but having an IDE is really awesome for a lot of reasons. Okay, so static application security testing. This is looking at your source code. I started down this journey by evaluating some plugins for my IDE for PyCharm, and I tested a couple of them. One that stuck out, and a lot of them actually recently had kind of changed hands or been abandoned or rebranded, and so this one is currently actively maintained. It's called the Python Security Plugin. It can plug into your JetBrains IDE, and also it includes some hooks into your GitHub Actions. I don't have time to cover everything today, but if you haven't checked out GitHub Actions, make sure that you do that. So over 20 built-in checks covering a lot of CVEs that are related to Python code. So let's take a look and see how it did. And the way that you execute Python security is you bring up your project in PyCharm, you say inspect code, inspect, I think is the menu item, and it will run through all of your code with the built-in checks that are in PyCharm, and in this case, the additional module of Python security. So I ran it against my project, and lo and behold, it found that I was storing secrets inside of my code, which I am, because future segments will cover how to use a password vault. I promise we will do that at some point this year. And when I looked at the code that it found and said, hey, you're storing your secrets in there, I was like, oh yeah, I found my secrets. And I looked, and it was just my initialization of a variable. It was an empty string. So did it really find a problem? In this case, not necessarily. However, if you look at the login code, so this happens to be in the authentication piece to the application, there are things that it's hard, especially for an open source project that is crowdsourced and volunteer people working on it. The complexity inside of code and the number of ways you can do things makes it hard to detect all the problems. So it may miss this problem that I've talked about in the past. Now, does anyone in the audience or our host know what happens if I uncomment this line right here and then comment out the line above it?
I do.
Matt knows because we had this bug.
Because we had this bug.
Yes.
Doesn't matter what username or password you use, it will authenticate you.
It will authenticate, right? If true means whatever you put in the username and password field doesn't matter. It's just going to allow whatever's in that field, or if that field is nothing, essentially clicking the login button will always result in a true condition and log the user into the application. Now, I did this because I locked myself out of the application. I did figure out why. It's because when you make some database changes, if you don't restart your application, it causes every user login to be rejected. I don't know exactly why that happens, but I know it's when you make changes to the database, you have to restart the application, and then authentication starts working again. Now, before I had figured that out, I had put this line in here and just let everyone log in because I locked myself out. I thought I locked myself out of the application. Then I forgot to comment it back out, and it was a problem for a little while. So those are the kinds of problems that I'd love to catch in the code development stage, right? I mean, you can easily check these and catch them later on by doing dynamic testing. But I would like to catch it in the code stages. So this is kind of a little nuance that SAST may miss. It may not. And you could also tune it to check for this condition as well. So then I said, well, let's try a different tool. And I found this other tool called Bandit, which looks at Python code and gives you a report of potential vulnerabilities you might have inside of your application. It's free, it's open source. If you search for Bandit Python, you will find its Git repository and some pretty good documentation as well. So let's give this one a try. First, I looked at some of the checks. So you have to select which checks you want to run. I purposely selected checks that I knew would, if the tool was working properly, find these conditions inside of our code. I knew I had hard-coded password strings because we're still looking to implement a vault. I know that I have code that uses URL lib, URL open. So I have those two examples. So when I ran this with the checks, and these checks 201, or I'm sorry, this is for the check for URL open, so it's check number 310. You can see that in the list. I ran that against our code, and it found some results. It gave me a medium severity with a high confidence that I was using this particular function inside of Python. Now, does anyone know why this could be a potential security issue? It's hard to interact with the audience when questions are relayed to me. So Matt or Utsav, why is this a potential security issue?
Allows you to load other libraries, I believe, from within the application if they're not currently installed.
Yeah, I mean, there's no execution path. I mean, there's no entitlement lock. It's just letting you execute whatever is available in the local directory.
Yes, so you can, if you have a library that's using URL lib to go out to the internet and pull stuff down, that could be a poisoned library. Right? Someone could have uploaded a Python library, changed a name, taken over a library. This is one reason why it's very important to get a handle on software composition analysis, because you could have libraries inside of your code that are pulling down other malicious code at runtime. And this check is looking for that and saying, hey, usages of that throughout your code, you should probably look at. Now, it's not a great check, right? Because there's kind of some false positives. The last one there, I'm pulling like an internal URL, and it's flagging that as a potential issue. So these would be ones that developers would have to look at, make sure that it's our code, that we're pulling code down from URLs that are authorized, and that it's not some poisoned library within my repository that I've imported. Which you should probably also check not just your source code directory, but your library directory as well. So your Python environment and all of the libraries that you're pulling in, check that as well. So this check right here is looking for hard-coded passwords. So I ran this yet different tool, Bandit, right? And I said, well, why don't you go find where I might have hard-coded passwords in my code? So I ran checks 105, 106, and 107, which looked for that. It did a much better job than Python security of finding these areas in my code. These are actually the areas in my code where I have a function that is setting those hard-coded credentials, largely for API keys and other such things, that I put in a function so that eventually every piece of the code would call this function. This function would go out to the vault, pull the credentials back in, and then return it to the application, right? You could use an API gateway. There's a number of ways to skin this cat, but this is where we are today. Not yet.
But you haven't yet.
Not yet. Not yet.
You haven't skinned that cat yet.
Not yet. Well, we are working on a cloud-native version of this application, so it remains to be seen. That will probably live in the newer version. But this did find most of my hard-coded passwords that were in my application. And this is bad. I mean, it's not horrible. I mean, it should probably live in environment variables, not inside of the code, because this code obviously is going to get checked into Git. So this is not the way to do it. We inherited a bunch of legacy code, and that's the way it stands today. But the point is, Bandit did a good job of finding this stuff and telling us where in the code we had hard-coded passwords. Alrighty. So those are some basic source code checking tools. Now I want to talk a little bit about the Docker deployment. You should consider using Docker for your applications and open source software deployments. And that depends on a number of different things. Containers are a nice way to deploy your application and have a little more control and some portability. Now, here are some of my rules when you're working with Docker and containers, especially in production. Build and configure your own containers and images, right? There's a number of reasons to do this. One is to prevent tampering. This sets you up for checking your supply chain and having control over your supply chain when you build your own images and containers. Customize the Docker file. So in building your own Docker containers and images, you're going to control the Docker file that creates those images. And you should not run as root. And I'll show you examples off of Docker Hub. Many of the default ones, most of them actually run as root. And I'll show you how to use multi-stage builds that will reduce your footprint and attack surface. And much of the multi-stage is to control the size of your container, but it also controls your attack surface as well. Then push your images to your own registry and vulnerability scan them in the registry. Amazon's registry does this by default. Docker Hub does not, and they didn't have an option, at least in the account that we have set up. I did not see a way to look at a report from Docker Hub for my own images if you have a commercial account with Docker Hub. So let's look at a multi-stage build. You can see the first line there says, from Debian Buster Slim, that today is my starting point. I mean, you can get really nitty-gritty and basically roll your own Linux distribution if you wanted to for your own containers, which I'm aspiring to get there. For now, I like Buster Slim as a starting point. It's a really good operating system. I like it better than Alpine. Alpine doesn't use libc and reports to have some other issues in production in my research. So I do this as, you can see, as compile image, right? So this is my first image that I'm building, right? And I'm basically going to leave most of this image behind. So this part of the first stage of the build configures and installs all of my software, and it needs curl and git and php to get in there and configure everything, right? Now, these packages that I'm installing in this stage of the build will not carry over into our next stage. So to ease the burden on your software composition analysis, using multi-stage builds allows you to include less software inside of your containers. Byproduct is your containers are smaller and have less attack surface. So all of these things... Go ahead, Matt.
Especially if it's PHP.
Yes. Yeah. PHP. Oh, yeah. So this is my custom MediaWiki build that is an example here. So the other thing that you can do, I think these are out of order. Yeah. Sorry. So once you go to the next phase, you're going to do inside of your Docker file now. This is the second half inside the same file from Debian Buster Slim as your build image. Now I'm creating a new container image, leaving behind all of the previous layers from my previous stage of the build. And all I do is I copy the results of my build. So I built a bunch of stuff. I put it in the var www.html directory. And from compile image, I am copying over the results of that previous image. And then, so which is nice, all those packages aren't installed here. Only the packages I need for production are installed in this stage of the build. My user, you can see I'm also dropping my permissions down to www, which is a new user that I've created, and set the permissions accordingly so that the PHP FPM server can run with non-root credentials. And you may say, well, why didn't you just pull from Docker Hub and pull down PHP FPM and run that? Their default image runs as root. If you don't believe me, the box on the right-hand side of the slide gives you all of the commands that you need to run on Linux in order to test that out. So I built a Docker file, I built the image, ran it. When I execute, you can see I'm at a root prompt. So by default, they run as root. Now, they do have documentation to say, hey, in production, you shouldn't do this, and hopefully people heed that warning. But for this, it's actually not too bad to drop down to a non-root user during the build process. So one thing when we're working with Docker files, there is an open source product that I like called HadoLint. And I apologize, the URL kind of got truncated there. The T is on the next line. It is on github.com as HadoLint, H-A-D-O lint. And it's really super easy to run. I mean, you can execute it just as a Docker container on the fly. You give it the input of your Docker file. It reviews your Docker file, basically linting your Docker files for you, and gives you security recommendations. Now, it's got a much longer list of security recommendations on the website. The ones that were affecting some of our Docker files were its recommendation for, well, instead of just, apt install a package, you should specify the version of that package. And I'm like, who does that? Like, really? I mean, that could almost have a negative security impact if there is a new version of that package. Now you have to go manually update your build config to go to that next version. So it requires a lot more planning and I think process to be able to do it that way. What I tend to lean towards is building my environments, building my containers with the latest versions of all the packages and frameworks and my latest version of the code, spin it up in a test environment, run all through your QA and security checks. If it passes, push out those updates to those versions. I like that approach better than trying to pin certain packages and or libraries. In Python as well, you can do the same thing, pinning those down to a specific version. If you've got the staffing and resources and process down, I could see you doing it that way. But I think for many, pulling down all the latest versions of libraries and packages and frameworks and then spinning up in tests is the way to go. See if I can get it to go to the next slide. Okay. So NGINX is a bit tricky to run as non-root, so we do build a web server container based on NGINX that is actually the web server for both our wiki instance and our production Python code. And I don't like to run NGINX as root. It's a little trickier. There's a few more steps in there. One, you have to obviously change a bunch of permissions on some directories, drop your user privileges, but also with the web server, it listens on ports less than 1024, which on Linux systems require root access. And so what you have to do is, with Docker, this is awesome because I can tell the Docker container config to listen on port 8080 and 8443. Then in my Docker Compose or in Kubernetes or whatever container management you're using, map those ports, map port 80 to those higher numbered ports, allowing you to run NGINX as root, which is pretty cool. I don't know why I can't advance the slides with the... The other thing that was a lot more complicated about the NGINX container as well was, for security reasons and operational reasons, you want to be able to change the environment on the fly, right? Where it reads its SSL certificates from, where it's reading in any credentials that it needs in order to operate, you want to be able to change on a per environment basis. Well, you can't do that inside of a container that has a configuration file for a service, such as NGINX, that's not reading the configuration items from environment variables. To do this in NGINX is kind of messy. I chose, and there's a few different ways to do it. I chose to use the env substitute, env subst command that will read environment variables with the fancy alt command. and based on a template, search and replace things in the template with environment variables is what that's doing. So it's taking in a template and spitting out a new NGINX configuration file every time that you're spinning up this container. So that is the way to do it for NGINX. It's documented on their website as well. And then what you get, in your NGINX conf or template, right, is you're going to listen, and then your HTTP port is an environment variable rather than port 80, right? So you can change all of this stuff on the fly based on your environment. And that basically sets us up to use to manage secrets through environment variables. Obviously, vaulting is a much better way. But now, because we can control the environment variables, we can randomly generate passwords, stick them in an environment variable, and the runtime container will read those. One of the interesting tricks that I've done is to randomly generate a password. If you're pulling down a brand new database image, and your database is brandy new, you can specify the database passwords, and I've got an OpenSSL command in there that essentially generates a random string. So this makes it easy to change, right? If one of your passwords or secrets leaks out in Git somewhere and you need to change it, it's really hard to roll back Git and remove those commits. So the strategy is to just change your password and or secret, and this makes it pretty easy in this particular build environment. And I am using environment variables, which isn't necessarily the best way to do it, but it works for now, short of a vaulting system.
And it's better than hard coding them.
And it's better than hard coding them. Yeah, I mean, this is the progression, right? So for MediaWiki, I had to, since its configuration file is written in PHP, I had to write some PHP code. I actually found someone who had done it before. If you search around the internet, you'll find there's an outdated GitHub repo that shows you how to do it. It basically, you just write some very simple PHP code to read environment variables to set the configuration items, such as the database password, and that's pretty straightforward. And you can customize your entire MediaWiki instance through environment variables. Just a little bit of PHP coding, which isn't too bad. Okay, so what does this mean? It means we have more of everything, right? If we look at some of the traditional ways in which we were deploying applications, whether they're our own applications or whether I'm customizing an off-the-shelf or open source application, I've now got more of everything, right? I've got an IDE that can look at source code for vulnerabilities. I've got configurations in Docker that need to be analyzed to make sure I'm doing things securely. Am I protecting my secrets? Am I introducing vulnerabilities? Am I actually running as a non-root user in my Docker configurations? Am I including vulnerable packages inside of my Docker build configurations? Am I including vulnerable Python libraries? Is my Python code secure? Am I on the latest version of Python? I am not. This project is still 2.7. And it gives you this big warning that it's end of life, right? Then once all this is built, I forgot to put a logo for Git, right? Code goes into Git. There's some Git actions there. Git has its own configuration. Make sure the repos are private. Git does its own analysis of the libraries as well and tells you if you're including vulnerable ones. So you need to incorporate that into your process. Then it moves over to Jenkins. Jenkins is build automation CI/CD tool. Maybe not the best one, but what we're using today. Jenkins needs to be updated. Jenkins has plugins. Jenkins has configuration. You actually write code inside of scripts inside of Jenkins. So all that needs to be checked as well. And then we also deploy this out to the cloud. So we're using Amazon's container registry, which again has vulnerability checks built into it. We're using EC2 right now to deploy these containers. You could use ECS if you wanted to. You could use hosted Kubernetes. And we're using Amazon's RDS. Now, all of these AWS services have their not just secrets, but also configuration and also versioning. You have to pick which version of the database you want to run. You have to manage the certificates in RDS. So all of these pieces come with configuration and management, giving us basically more of everything. It's more code, more configuration, the more you build out your DevOps process and CI/CD pipeline. And you definitely need help with that. I know I do, which is why Utsav is here from Synopsys to talk about some of the commercial offerings and solutions that you have for these various problems. Utsav, over to you.
Awesome. Well, thank you. Thanks for having me, guys. I think some of the problems that Paul identified, I think they're so sort of right in the wheelhouse of what we run into when we talk to customers. I mean, the example with Lint, right? I mean, is the open source dependency something that you as a developer, for example, have introduced, or is it a transitive that a declared dependency is actually referring to when you're pulling it in? And how do we get to the bottom of it? And even with the Python security tool that we talked about early on, right? If you just comment it out and you just set the function to true, it basically doesn't need any authentication, right? How do we factor in those albeit trivial changes? How do they impact the overall application, right? So we need a formal AST solution that can, and I like to simplify this by saying you can zoom in when required and look at those really small incremental changes, and then zoom out, looking at the context of the entire application and figure out what implications it might have, like into procedural issues, etc. So what I wanted to do today was sort of walk you guys through the application security landscape and what the different components are, and why, Synopsys as an organization, why are we providing for, and why are customers today buying commercial tools, although there are open source solutions available that offer some flavor of that. So we've seen, as we get more complicated, as we pull in a lot of components that make up the application, the overall complexity of your application is going up. I mean, there's, if you look at a typical application, there's the operating system layer, there are apps on top of it, and you have multiple microservices running on top of that as well. And it's super complicated. And that complexity is made more significant when you add the whole go-to-market pressure. Like, everybody wants to be the first one out there with their product, with whatever service offering they have. And so this need for velocity is a big requirement. So that is also one of the reasons why developers will lean on using open source as an example, as opposed to writing up the code themselves, right?
Yeah, that's a great point.
And so if we go to the next slide, I think it's important to understand that if you look at the different areas of the code, there's proprietary code, there's open source, there's additional frameworks on top. If you're licensing some libraries from, say, an Amazon or from Microsoft or Oracle, how do you factor in those pieces, right? If you're using some external third-party API, let's say you're writing a payment app that's basically interfacing with a banking application, right? There's going to be a lot of back and forth of data leveraging APIs, and do you know the response of those APIs? So I think the point I'm trying to make is, the more complex your application, the more difficult it is for one tool to satisfy everything, which is why what we've done on the Synopsys side is we've deliberately cherry-picked the best-of-breed solutions with, Coverity for proprietary code, if you go to the next slide, and then the Black Duck component for SCA, and then IAST for for all of the API fuzzing, and our most recent acquisition, Tinfoil, that helps you understand the content of your API response and see if your payload has any potential security vulnerabilities, right? So we've tried to sort of first map out the overall landscape of where really is application security required, and then try and build out a portfolio with the whole suite of application security tooling so that we can address all the necessary problem areas.
Utsav, what's the difference between the Coverity and the Polaris platform?
Great question. So what Polaris does is Polaris is actually putting together the foundation of having all of these individual products, be it Coverity, be it Black Duck as an example, to come together and interface with each other. Because at the end of the day, the silos that used to exist back in the day are disappearing. Mm-hmm. We see those walls collapsing, because if you look at the most critical user in the application security context, it's actually not the security person, it's the developer. Mm-hmm. The developer has to make that change. The security person is the guiding light who's helping them understand, okay, this is how you do it, these are the policies. But when we do that, the developer at the end of the day needs to be empowered. And the developer doesn't really see that line. They don't really understand static analysis. They don't really understand the SCA component. For them, they need to complete these these security guidelines as mandated by the security organization.
They need to
finish them up.
They need to close their JIRA tickets, and it doesn't matter if it came from static analysis or the DAST or protocol fuzzer or SCA, right? Doesn't matter.
Right.
At the end of the day, it has to get prioritized and be a JIRA ticket for a developer to fix.
Yep. And so what the approach we've taken is Coverity is very static analysis only, right? With Polaris, you're now able to elevate that and look at an application from the context of what's the risk? What's my overall risk with an application, independent of the underlying technology? Because at the end of the day, if I'm an executive persona who's trying to evaluate the risk within my organization, I want to understand. Let's say hypothetically, I have 600 applications in my portfolio that I'm managing from a risk standpoint. These 10 applications are the problematic ones. This is where I need my team to go back, put together a remediation plan. And so those types of insights get lost if you're just sort of looking at the silo of a tool. So Polaris, to answer your question, helps bring that elevation and the correlation of the tool, and doing this in such a way that everything else is invisible, so that the customer only sees what they want to see, which is what's the risk from an application security standpoint.
Right. So think of it as kind of an application prioritization dashboard, right? It's integrating the results from all the different application security products in the portfolio, rolling them up to a single application so you can really understand the overall risk and priority of those activities at an app level, right?
Mm-hmm. And then does it do some consolidation? Like if Coverity found a vulnerability in the static analysis phase, and then the protocol fuzzer found that very same vulnerability, but through fuzzing, does it? I'm assuming that it's one ticket rather than two, right? Basically,
correct. It normalize it. Not only, I mean, aggregation is part of it, right? Aggregation is not a problem. It's the normalization which is the tricky part, and so we normalize it so that at the end of the day, you don't have to, solve one problem twice, because IS found it and even static analysis found it, right? So we will reconcile the results, we will normalize it, and we provide. I mean, we see customers with production applications having 10,000 security issues, and the biggest challenge is they have vulnerability overload. How do we get from vulnerability overload to a state where they have a balanced approach as to how many pending issues exist and how many keep coming in on a daily basis? Because software development is not going to stop. Developers are going to do their job. They're going to continuously keep writing code, and it's going to keep pumping into the system. And you have to make sure that not only are you putting together a process to fix your baseline when you first did your scan, you're also empowering the developers and all the subsequent personas in the SDLC to understand and stay cognizant of the necessary steps they need to take in the process so that the problem doesn't fester through the SDLC. I mean, it's like a typical, I would typically put it down like a very simple process, a line process where if something is wrong here, the build engineer is not going to look at it. I mean, it's going to follow through. So as opposed to having it go through and not have any stage gates in between, it just becomes a bigger problem, which is why, we acknowledge this macro trend, and we've realized that the developer is the starting point, and that's where we need to tackle application security.
Yeah, go back to that slide real fast, Paul, because I want to point something out, right? I mean, when you and I do a lot of analyst calls, and the one area that I trip almost every analyst up on is they ask me about application security, and I mentioned Synopsys. This is why. It is one of the broadest application security portfolios. I mean, you've got fuzzing, static analysis, software composition analysis, and dynamic, both at the web and the API layers with the tinfoil stuff, all in one portfolio. I mean, that is a breadth of capabilities that not really anybody else has built out, which is why I like what Synopsys has done with these acquisitions to bring it all together.
Yeah, it's really awesome.
Yep. And so I think this is a stat that I like to use from Gartner, where Gartner sees this macro trend and is forecasting that by 2021, by next year, DevOps practices are going to be so natively embedded into a rapid development team's processes that it's going to be up by more than 15%, which was the stat in 2017. So this is basically an attempt for organizations to reach that higher level of agility, lowering their costs and identifying the problem areas, which typically start with where the code is built, which is around the development environment. So everybody is sort of in favor of trying to empower them with the right tooling and processes. Next slide, please. So if you look at this, and if we double click a little bit on this and try and understand what the persona within the SDLC, if you look at the build release engineer, you look at the developer, what are the typical questions they ask, right? And this is what we tell our customers as well. We get customers saying, hey, we're moving away from a waterfall process to an agile process. We're somewhere in between. I want to understand how security can be embedded into that process. So they want to start, by understanding what we do, how does the tooling work, can it add more fluidity, or at least not slow down their existing, velocity? Because at the end of the day, you don't want a mission critical application getting delayed because a security tool is running. So it has to be inline, it has to be invisible unless there's a problem. So basically the notion is raise your hand if there's a problem. If not, let it flow through. And so the second trend is, how do I keep this up with development? Historically, security and development have sort of, had this sort of funny, dynamic where security would make processes and try to force those processes. Developers would not really adapt to it. Some will not, and it would lead to a lot of friction. And so how do you typically help bridge that gap? And so that's another big question that we get asked. As a corollary to the first question is, basically, if you do have something, how do I shift left? How do I shift further left in the SDLC? So even before a developer is even making a fix, just considering how to make a change, can you provide them with the right guidance? And this is where I like to throw in a stat that, study that Forrester did. So Forrester did a study of all the top engineering schools in the country and a few in Europe as well. Not a single, computer science program offers a course on cybersecurity, which is, wow, surprising. And so if I'm a new developer and I've graduated, valedictorian, top of class, I get a 6-figure salary going to Google, I have no idea what a cross-site scripting is. I have no idea what SQL injection is. And so in addition to, identifying the guidance and education aspect is a big thing our customers ask. And that's true because, there's no education. So even if you train somebody and to give them guidance how to fix it, how do we ensure that it doesn't happen again, right? We want to train them, improve the overall risk, their understanding of what qualifies as risk within the organization. And the last one is visibility, because at the end of the day, you want to see what's fixed, how was it fixed, is there any other impeding problems that are coming in the way from empowering these developers. And so this sort of covers some of the reasons why what we have, what Synopsys is doing, and some of the investments we've made, and some of the announcements we've made from a product standpoint in the past few months. Next slide, please. There we go. So I can quickly go over this. Some of the viewers have already seen some of this, but this sort of corroborates some of my earlier points, which is we see a lot of customers who are trying to push security within development. So as a survey that Forrester did in their most recent 2019 report, 73% of global security decision makers for bigger organizations, 1,000 employee plus, they want to improve their security processes, and then 41% from that sample set want to move their security into development. So we see this as a big macro trend that's emerging within the market. If you go to the next slide, that was just static analysis, and that's only talking about code that you as a developer have written. If you go to the example that Paul mentioned, if he's using some open source components, how do you deal with that? Again, static analysis is not designed to help you identify open source. You need more specialized tools for that, so you don't leave any potential security gaps in your scanning process. So open source, as we all know, is very widely used. It's up to 90% of most modern web applications today, and this is an area that oftentimes is ignored by users because they fail to realize that, static analysis is part of my code, it's going to identify open source. That's not true. So this is one area where I typically double click on and let customers and I want to let the audience know that this is something that we all should be cognizant about, because static analysis typically may not be more than, proprietary code may not be more than 20-30% of your code base. a big chunk of that's going to be open source stuff. And so you got to make sure you have tooling and processes for that as well. Next slide, please. Another stat I share is like if you look at on an average, right, we have more than 16,000 open source vulnerabilities that are disclosed every single year. And the process is you responsibly disclose them. They get published on the National Vulnerability Database. Tools pick up and they'll let you know. But given the sheer volume, I mean, it's such a compelling fact that it draws everyone's attention to how important SCA as a technology, software composition analysis, and open source risk analysis is in the context of application security. Next one. And so, yeah, if you just some more stats around the macro trends, why SCA is so important. I mean, we saw Paul's use case, but if you extrapolate that and look at it, holistically, you see that overall we have, we typically find 60% plus code bases on an average that we evaluate have open source. And when I say open source, they have 40% of the open source found has high risk critical vulnerabilities, the type that affected Equifax breach back in 2017. And then most of these vulnerabilities are so old that it's a big challenge. Like on an average, most vulnerabilities are over 8 years old. And that's a big problem. Like I know sometimes for ease of implementation, developers wouldn't even bother changing the version of a component. I have this component in my repository, it's in my Artifactory, or it's in some tool that's getting mirrored from Maven Central, for example. I will just continue using that without keeping in mind that there are underlying vulnerabilities getting exposed or getting created because it's an open source project, right? And not staying cognizant about it. So these are the things that really make SCA a big problem that we should keep an eye out for. And again, the goal is if we and Paul asked this question, right? What's Polaris? How is Polaris sort of helping here? So Polaris is basically trying to pick all these technologies together, bring it all together, ensure that you as a user of the security technologies don't get slowed down in the process. You can lower the cost of your overall implementation. Like security deployment can be expensive, and we help customers reduce the total cost of ownership. We reduce the friction involved in trying to use the solutions by deploying it at different levels, and then continuously providing feedback so that you know where you're falling short on and how do you fix that, right? So those are some of the macro trends that we wanted to talk about today, and it's a nice segue if you go to the next slide, Paul, into what we wanted to show you today, which is a live demo of how Synopsys is bringing this together at the IDE level with our CodeSight plugin. So I'm gonna share my screen here. Let me know once you guys see it.
Sweet.
All right. So I have a Spring Boot application. I like to typically use the Pet Clinic application. This is it again on GitHub. It's a very popular application that a lot of users use for like demo stuff. And what I've tried to do is I've tried to pull that project down and use it in the context of my IntelliJ IDE. And this is IntelliJ Ultimate. So I think it supports both the Java as well as JavaScript capabilities. Just like Paul, I'm a big fan of IntelliJ. It's a really nice UI. It's
JetBrains makes really nice tools. And looking at that interface, regardless of which one, you feel at home, right? Because they all have the exact same look and feel. So.
Yep. It's so consistent. It's so neatly designed that as a developer, it really tries to, and the usability elements are really nice. And so we can leverage some of the technologies that I'm going to show you right now. We can leverage them in such a non-intrusive, automatic fashion that it really doesn't become a security tool, but ends up becoming a productivity booster.
Yes.
Because at the end of the day, you don't start seeing this as, I got to run the security tool, go get a cup of coffee and come back. And so we've tried to sort of dumb it down to the best of our ability. And so let me walk everyone through how you would do this. And so you would start off by going to the marketplace. I would start by going to the marketplace here. I would search for the plugin. So CodeSight, and so whatever you see today is something we've made consistent across different IDE platforms: Visual Studio, VS Code, the Eclipse and all of the IntelliJ families. So that's PyCharm, WebStorm, PHP Storm, Ruby, RubyMine. So we've made sure that all of these IDEs are consistent. And just like you would download any IDE today, IDE plugin today.
I can't see that pop up. I mean, I know what it looks like because I used the tool and I did it earlier, but I don't know if that's landing on a different screen or behind it or something.
Oh, I think it's going on my other screen. That's why I just shared one screen. Let me just actually share my plug this thing out and share my desktop so you can you now see it?
Yep. Perfect.
So you search for CodeSide like you would search for any IDE plugin, and it will come up because the IDEs are typically connected to their marketplaces. And then you would install it, it would restart the IDE, the typical process, right? And then once you are done, you would see this view come up at the bottom. And in this panel, you would just be prompted to log in. Now, for the purpose of this demo, I'm already logged in, and so I don't see any message in my notifications view that's telling me to log in. But the typical login sequence would ask you to do something like this. Just enter your username credentials, your server, and you can enter your password. Same goes for SCA, and that's the only configuration. So what I wanted to highlight here is, be it static analysis or SCA, the configuration is very minimal, and all of the heavy work and all of the actual processes are happening in the background. It's automatic, and it depending on the code base and the files that are getting evaluated, it tries to understand what technology needs to be applied and runs that technology. So we do that configuration, we set it up, and in a matter of seconds, we automatically start seeing the scans happen in the background. So in my application here, I have a few Java files open. I have a POM file open where I'm actually making some dependency declarations under the dependency section on the POM. I actually don't have to wait for a scan to happen. Scans will automatically trigger as I make changes. So I actually set up this project like a week ago, and as soon as I added the project, it identified that this is a new project, and it automatically triggered a scan. To give you an example, let's go to the pet controller file here, and so I deliberately added the SQL injection snippet here, and as you can see, it's showing me there's a SQL injection because of the snippet that I've added here. I'm going to try and open this up so we know where this is pointing to. So it's right here within the issues list. So this is my SQL injection, and I can actually remove this, and it goes back to the sort of the inline change that Paul was talking about early on in the session. But if I make this change, do I need to run a scan for the entire project? Well, okay, you don't have to do that, because if you have to do that, it takes a lot of time. But then do I risk missing out on results? The answer is no. What we've done at Synopsys is we've very intelligently tried to balance that speed. So you can see from the list of SQL injections on the current file, there is no SQL injection. I will add this, and I'll hit save.
Utsav, the nice part too is it being in IntelliJ. When you remove a function like that, before you remove it, you can search for everything that calls it and update your code accordingly to call maybe the more secure version of that function. And then the integration, when I delete that class or method or whatever, it automatically updates my vulnerability report. The combination of the two is really awesome.
Yep, that's exactly how we do it. Yeah, we try to make sure that we give you best recommendations, and we try to leverage existing tooling that exists within the host IDE. So in this case, IntelliJ offers a lot, and typically developers will have that installed on their laptops. When we talk to enterprise organizations who have like 15 to 20,000 developers on file, they may be a little restrictive on what their developers can install. But typically, I've seen like big banking organizations, financial services, healthcare, they're pretty okay with making the developer make the right decision on what to use. And so the intention here was to have organic interest build in security and be able to use that, because the number one complaint historically we've heard in this area is it's too slow, it takes forever to scan, it doesn't give me the context that I need. And so making it as focused as possible is what CodeSide strives to do. So while we spoke, less than 5 seconds, the SQL injection popped back up, and you can see this, and it's again back here, so you can see the issue details. You can understand how this is coming up. So I can open up the call graph view, so it tells me line number 116 is actually a supporting event, and the actual function, the actual class is this one, the class SQLi that I created. So helping the developer pinpoint to the problem area and trying to understand how to solve it is what this call graph view gives you. And then it shares, it gives you additional details about security metadata, any CWE it maps to. So in this case, it goes to CWE 89, which will open up, back, on the National Vulnerability Database that MITRE is managing with the NVD Council. Then how do you resolve it? Is sort of the resolution steps. And then more importantly, SQL injection, the injection category is part of the OWASP top 10 checker list. And so this comes back to my earlier comment about education, where we actually add details and we provide coursework that links to Synopsys' e-learning capability, where we provide small, very effective micro courses for developers to understand what is OWASP top 10. Like, why am I getting this prompt from this tool, right? And that's where we sort of round it up with the education aspect. So this is static analysis, this is education. And then if I open up the POM file, once I open up the POM file, there's nothing in this POM, but once I try to look at the SCA view, I start seeing that I have a lot of SCA issues here. So let's look at this one. Actually, I like to look at this one. This is one of my favorites. Apache Tomcat, right? Apache Tomcat. I'm using this web server here. I have a favorite version. I'm just too lazy as a developer to change the version. And so how do I know if I'm making the right choices, right? So a tool like CodeSight within your IDE can help you understand what version of the component you're using. How do you fix it? So fixing it is as simple as upgrading to the next fixed version, which is the 9.0.13 Atlassian hosted patch that the community supports right now. Or you can actually update to the most recent one, which is the 10.0 release and the M4 patch, right? Both these versions have no known vulnerabilities. So you're okay. You basically have to make a decision. Do you want to use the most recent one, or do you want to use the one that's right after this? And I'll draw some attention why we do it this way, because we see a lot of customers because this involves a version change, right? We have a lot of customers who don't really want developers to use any random version that's out there. They either use the one that's the next best because there were vulnerabilities identified in the previous version. And some people don't really have those restrictions. They're okay with developers pulling the latest and greatest. I mean, I personally like to use the latest and greatest because I know everything, any underlying problems have been fixed, right? So
yeah, but
that doesn't exist in production.
What I love about this though is it gives you a better path, right? You could jump to the latest and greatest version, but there's been a lot of changes in Tomcat, for example. You'd probably have to, depending on your code base, make a lot more changes if you went to version 10. But you also have the option to go to the latest, the next safest version. Maybe you're going from version 7 to 8, right? And do that first, fix all of your code, push it through a couple of build cycles, then go, okay, now I'm going to update Tomcat to version 10 and deal with the next round of changes. So it lets you break up work into smaller chunks, which is a DevOps part of the DevOps philosophy and just a better way to implement software.
I completely agree with you. Yeah, I mean, what we're trying to do is reduce developer fatigue when it comes to making these changes, because these can be overwhelming. I mean, another use case scenario that I constantly see is where developers inherit code, and some of the outgoing development group or an outgoing senior developer has a bunch of dependencies. I mean, and these can be in the hundreds. Scouting those dependencies, changing them, rerouting your application to use a new set of dependencies, making sure nothing is broken. I mean, it's a pretty significant amount of time that's going to go in doing that. And so the easier path to getting their changes done is let those dependencies live. Just add the ones that you want to add, or you want to change from Tomcat to a different web server, for example, or you're using Jackson Bind as Jackson Bind used to be a pretty common component back in the day, and until recently when a critical vulnerability was found sometime in 2019. So you could just make that decision, reroute and rewrite your application to point to those newer dependencies and just move on with your day. But then if you look at the other SCA tools, right, that are in the market, they would just parse your POM file or your build.gradle file and give you everything. Now, in this case, in my example, you have 100 dependencies, but only a subset are actually being called in the application. How do you make sure that you only flag those 30 and not the remaining 70? And so that's what this technology ensures we do by bringing it all together, because we have that context that hey, this older dependency is not getting pulled in, so no point bothering the developer by flagging it as a vulnerability. Hey, you have a problem with this one. Well, obviously that was last updated in 95. We're in 2020.
Yeah.
So
now, does it look at your usage of those included libraries? Because oftentimes what I found is, tools will say, hey, you're including library version 1, and it had a vulnerability in this particular function or method. And then I look through my code, I'm like, well, I'm not using that method. I'm using some other methods in there, but not that particular one. Can you get that granular with it?
So the black duck technology in general looks at that. So the black duck technology has 4 scanning techniques. There's the dependency inspection, as we call it. There's signature scanning, which looks at the file level. And then once we see an exact match at the file level, if we see some fuzziness within the file, meaning if you've modified an existing open source project or a set of files, and you've made changes to the underlying function, we have something called a snippet scanning that basically tries to see what snippet of code is really the problem area here, and is it really causing the problem that you're talking about? And we do all of that validation process in the background to make sure that we give you the most appropriate and the most accurate match.
Sweet.
And so that's a really great question, because I think this sort of puts us in a good way to sort of bring up the point about false positives, because you see open source tools sometimes, or some other vendors who would just flag what's in your POM, like just run a simple grep function on your POM file and just pull everything.
Yeah, that's what I think. GitHub and Amazon's ECR, that they're more like I'm just going to look at the versions that I have in this file that tell me it's vulnerable, and I'm going to look at your packages and just do a basic comparison, right? Yep. It's not going into those other methods that you talked about with Black Duck, and that's a big differentiator, because you'll get false positives with the other ones.
Yeah, and some of them even struggle, because if you look at most modern applications, right, like even in this example with my POM, I'm not providing a version. I'm actually providing a variable. There's tomcat.version as my variable. And so whatever resolves at build time will be the version that gets pulled in. Yep. And if you're grepping the POM file, you never get the version. Your guidance is flawed. So that's what we do differently with Black Duck and CodeSight coming together. We make sure that we are identifying the right version, and we're calling the right. So in this case, I'm just saying Tomcat servlet API. I'm just specifying the Tomcat version. It's actually 9 or 12 that's getting resolved. And so I have that information depending on how you've set up the code and the other metadata that already exists. And then as you do a build time and again, I can pull that metadata and I can archive that information and persist that, so that when required, I can use that information. And then the last thing I want to show you is some of the vulnerability data. So BDSA is the Black Duck's security advisory data, which is proprietary to Black Duck, and this is coming out of our security advisory team that is sitting in the security capital of the world, which is Belfast in Northern Ireland. And we have a team of dedicated researchers who look at threat models, who look at using the STIX methodology to identify if any potential vulnerabilities are actually getting developing, or the application or the component actually has been designed in such a way that it's a security flaw, right? And so we try and flag that and create a record early on, as opposed to it getting identified, getting verified, and then getting published at the NVD level. And the reason this is a problem is the NVD is doing a fantastic job, but it's more like a community project, and it takes a while before a vulnerability is actually confirmed, verified, and then published.
Not every vulnerability in every library in open source component or package gets a CVE. And what it sounds like, Utsav, is that you have a team that's looking at that and flagging stuff that could be vulnerable, even though it may not have an official CVE number.
Yep. And so we look at that and we try to figure out, okay, I think this is a defined vulnerability. We should alert our customers. And so we did some analysis back in 2018, 2019, and try to compile sort of the time ranges of how frequently does it take for a vulnerability to actually be exploited and then be published on the NVD as an actual vulnerability. And the time average we received was anywhere between 6 to 8 weeks, which means that if some company's code base was exploited today, and if you were not aware of it, it would take 6 to 8 weeks before it would be published on the NVD and then be broadly made available, which means that same hacker that malicious user can potentially target your application if it's using the same component for the next 6 to 8 weeks. And so that's a problem.
Yeah, because oftentimes the open source project or whatever library won't find out that there's a vulnerability until someone notices a machine or application that got exploited and goes, hey, what? I didn't know there was a vulnerability in there. And then you dig into it and it's like, oh, that was a 0-day vulnerability. And then it's 6 to 8 weeks before there's a CVE published, which means you could be vulnerable for a couple of months.
Which means it's 6 to 8 weeks before somebody builds a signature to detect it to now report against it.
Correct.
Yep. And so we use the BDSA framework to publish those vulnerabilities. And as and when CVEs come up, we will add them. So as you can see, even for Tomcat 9012, a lot of the records are all BDSA because there's no corresponding CVE record yet in the NVD, which is why we only show you the BDSA records. Like for the 2020 ones that just got published, there is now a CVE associated with it as well. And so we reconcile them and we show them. But the BDSA record typically features first so that you know how you can fix it and how you can patch it. And I can give you an example of this as well.
Yeah, that was a newer one. We actually covered that one on a previous show.
Gotcha. So how do you fix it? We give you commits so you can just copy the patch and just use it.
Yeah, that's basically disable your AJP library or connector.
Connector. Yep.
Yeah, that's a config thing.
Yep. And then, we give you like basic metadata, what the license is, what the license family is. It's permissive, so no problem for you to use if you have a external shipping application. No open source liabilities there. When was it first detected? These are some of the pieces that help from a global management standpoint. Okay, what open source was, because some have compliance needs, right? They're obligated to fix certain underlying problems once it is flagged. And so we make sure we expose that. So as part of reporting, we can show that and help organizations stay compliant. There are organizations who follow the OWASP standard with OWASP top 10. Some of our healthcare customers follow the HIPAA standard. Some of the financial customers follow the PCI DSS format. And so we help with all that reporting aspect as well. And that's basically how we do it.
Awesome. I know we're a couple of minutes over. I didn't see any questions come through the chat channel, but if anyone has any questions, you know how to get a hold of us. You can email us or for Synopsys, go to their site. And I'm assuming you have a way to get a trial demo and interface there. So by all means, go do that. And we don't have any questions, so that will conclude the broadcast for today. Matt and Utsav, thank you very much. Thanks, everyone, for tuning in today. We'll see you next time.